Helicopter Flying Handbook 11.7 Helicopter Emergencies and Hazards. When a helicopter faces a single engine failure, maintaining altitude and airspeed becomes a balancing act, contingent on various factors like weight, density, altitude, height above ground, airspeed, and phase of flight. The absence of telltale yawing, as seen in multi-engine airplanes, makes identifying the malfunctioning engine a challenge. The cautionary note here is to avoid shutting down the wrong engine, a potentially disastrous move. Even in multi-engine helicopters, preserving rotor RPM is non-negotiable due to documented cases of both engines failing in flight because of fuel contamination. Should both engines decide to call it quits, the helicopter glides into an autorotational descent. As airspeed climbs above 70 to 80 km or knots indicated airspeed, the descent rate and glide distance surge. Conversely, as airspeed dips below approximately 60 knots indicated airspeed, the descent rate increases, and glide distance decreases. Getting lost is a peril that pilots face for various reasons. When it happens, the priority is to fly the aircraft first and then initiate lost procedures. The workload surges, and heightened concentration becomes imperative. Simple yet effective lost procedures include locating large landmarks for chart reference, climbing for better visibility and communication, employing navigation aids, dead reckoning, and pilotage, and reaching out to air traffic control or ATC for assistance. The 4 C's are climb, communicate, confess, and comply. Offer a handy mnemonic for pilots in distress. Climb for a better vantage point, improved communication, and navigation reception. Communicate by contacting the nearest flight service station or automated flight service station or AFSS, and if that fails, switch to the emergency frequency that is 121.5 MHz. Report the situation to air traffic control, confessing the lost status, and comply with controller instructions. Information provided to air traffic control should include aircraft identification, type, nature of the emergency, and the aviator's desires. Preventing loss in the first place involves strategies like flight following, monitoring checkpoints, tuning in navigation aids, and maintaining situational awareness. Flight following enhances surveillance and aids collision avoidance. In the event of getting lost and being low on fuel, a precautionary landing is advisable near a road or an area allowing another helicopter to land safely for assistance. Waiting until fuel exhaustion is risky due to potential engine stoppage caused by fuel sloshing away from the pickup port. Land safely, seek assistance, and prioritize safety over the inconvenience of a minor fuel delivery. Helicopters primarily operate under Visual Flight Rules or VFR, relying on visual cues for aircraft control. However, unforeseen weather changes can lead to inadvertent flight into instrument meteorological conditions or IIMC, posing a life-threatening emergency for pilots. Inadvertent instrument meteorological conditions onset can be gradual or sudden, lacking a simple procedural exit. Unlike flight training in visual meteorological conditions or VMC, most training helicopters lack instrument flight rules or IFR capabilities. General aviation or GA helicopter pilots may lack exposure to actual instrument meteorological conditions or IMC during training, making encounters challenging. Inadvertent flight into instrument meteorological conditions can induce physiological illusions, leading to spatial disorientation and loss of aircraft control. Despite some instrument training, many helicopters lack augmented safety systems, making inadvertent flight into instrument meteorological conditions emergencies daunting. The reliance on outside visual references is inherent in helicopter pilot training, necessitating significant instrument training, which can be intimidating and costly. While commercial helicopter operators prefer instrument-rated pilots, fatal accidents still occur due to pilots' inability to recover from inadvertent flight into instrument meteorological conditions, even with adequate equipment. Therefore, all pilots, whether instrument-rated or not, must prioritize avoiding inadvertent flight into instrument meteorological conditions. A crucial safety practice for any flight involves establishing and adhering to personal minimums, which should be more conservative than the regulatory requirements for Visual Flight Rules or VFR. A comprehensive pre-flight assessment, coupled with an understanding of weather conditions that may contribute to the risk of instrument meteorological conditions or IMC along the planned route, is essential for safety. Pilots should be vigilant in recognizing deteriorating weather conditions during flight. If conditions fall below the pilot's personal minimums, it signifies an en route decision point. At this stage, the pilot must decide to either return to the departure point or land immediately in a safe area until the weather improves. Descent below a predetermined minimum altitude above ground level or slowing the helicopter to a predetermined minimum airspeed indicates that the decision point has been reached. Ceilings lower than reported and/or deteriorating visibility along the route should prompt a decision to discontinue and alter the current route to avoid inadvertent flight into instrument meteorological conditions. For instrument-rated pilots, maintaining instrument currency and proficiency is advisable, aiding in a safe recovery from inadvertent flight into instrument meteorological conditions. Planning for visual flight rules flights should include a review of published instrument charts for safe operating altitudes. In the event of inadvertent flight into instrument meteorological conditions, the pilot may consider a climb to a safe altitude. Once stabilized, the pilot should promptly declare an emergency with air traffic control or ATC, emphasizing the need to prioritize aviating, navigating, and communicating. For pilots not instrument-rated, current, or proficient, are flying a non-instrument flight rules-equipped helicopter, remaining in visual meteorological conditions or VMC is crucial. Attempting to maintain flight solely by visual ground reference, especially at lower altitudes just above trees or by following roads, is risky. This practice can lead to fixation on what is below, hindering the pilot's ability to perceive hazards ahead. Continuing visual flight rules flight into instrument meteorological conditions can result in fatal outcomes, as pilots may be unable to avoid obstacles or become disoriented. Night flying requires even more conservative personal minimums to ensure safety and prevent inadvertent flight into instrument meteorological conditions. Deteriorating weather conditions may be challenging to detect at night, emphasizing the need for thorough weather briefings and vigilance for unexpected weather changes during the flight. Planned routes should include pre-selected landing sites to provide options for precautionary landings if needed. As pilots gain night flight experience, their ability to assess weather conditions during a flight improves. Maintain visual meteorological conditions during flight by promptly reversing course if visual cues deteriorate, refraining from proceeding in unclear terrain, and contemplating flight delay or cancellation in questionable weather. Always ensure a safe landing area is identified for every route of flight. In the event of inadvertent flight into instrument meteorological conditions or IIMC, pilots should be familiar with 5 essential steps that should be executed immediately if applicable. However, it's crucial to note that executing these maneuvers solely by reference to instruments requires training, and if the aircraft lacks such instruments, this guidance may be less beneficial, leading to potential loss of helicopter control. Pilots should level the wings by using the attitude indicator to level the bank angle. Next, they should set a climb attitude to achieve a safe climb speed, typically no more than 10 degrees of pitch up on the attitude indicator. Verifying that the selected attitude has achieved the desired airspeed is critical. Slower airspeeds, closer to effective translational lift, may require significant control inputs, decreasing stability and making recovery impossible while in unintended flight into instrument meteorological conditions. Adjusting to a climb power setting relative to the desired airspeed should be done concurrently with attitude adjustments. Maintaining a heading known to be free of obstacles is essential, with the heading bug set to avoid over-controlling the bank. Coordinated flight is crucial to prevent unusual attitudes. It's advised to avoid an immediate 180-degree turn, as it may not always be the safest route. If a 180 degrees turn is deemed the safest option, pilots should note the current heading, begin the turn to the reciprocal heading only after achieving stable flight and maintain a constant rate of turn appropriate to the selected airspeed. Every encounter with unintended flight into instrument meteorological conditions is unique, and no single procedure can ensure a safe outcome. Considerations in determining the best course of action should include terrain, obstructions, freezing levels, aircraft performance and limitations, and the availability of air traffic control services. As technology develops, new aircraft design, enhanced technologies, and lower-cost solutions are emerging. The integration of helicopters into the national airspace system, increased instrument flight rules infrastructure, and instrument training are expected to become more prevalent, potentially reducing the severity of unintended flight into instrument meteorological conditions emergencies. A helicopter instrument rating is highlighted as a potentially life-saving addition to a pilot's certification level, with additional resources recommended for exploring IFR operations and obtaining an instrument rating. In the context of survival gear, both Canada and Alaska mandate pilots to carry survival gear, especially when flying over rugged and desolate terrain. The choice of items depends on weather and terrain conditions, considering storage space and the impact on overall weight and balance. In summary, anticipating emergencies, being knowledgeable about the helicopter and potential malfunctions, and planning for safe exit paths or procedures to compensate for hazards contribute to safer piloting practices.